Okay, class, so here's another example from section 5. Here's another example from section 5.7, the start of the recording. All right, I'll give you a chance. This is sort of an amazing integral, isn't it? All right, we'll take a look at that. And all right, and right now we'll proceed on here. And don't worry, I'll make the assignments active again. Okay, so give you a moment to copy this example down. This is an extremely important example. You're going to see this kind of example in differential equations, Math 282. Okay, so we have the integral of this rational function. We have an integral of a rational function, 2x squared minus x plus 4 divided by x cubed plus 4x. Now this kind of problem, you know, our techniques that we learned are not going to be adequate to solve this problem. We're certainly not going to, well, all right, so we have to think about what do we do here? What do we do? Well, we're going to use a technique called partial fraction expansion. And what we have to do, first of all, is if we look at the denominator, x cubed plus 4x, is there something we can do with that? Something that we kind of like to do in math? That's right. That's right, Tina. We can, Candace, that's right, Tina, and hold on, there was another person too. And not Nail. Yes. So we're going to do that. Now watch what I'm going to do. I'm just going to show you the process because, all right, what I do is I say, okay, my integral equals the integral of 2x squared minus x plus 4 over x cubed plus 4x, and I factor the denominator. My goal is to rewrite this fraction into an integrand that I can integrate. I can't integrate that right now. So I do what's called a partial fraction expansion. Partial fraction expansion. Trying to. So believe it or not, I can write this rational function 2x squared minus x plus 4 over x times x squared plus 4. I can write that as the sum of two other fractions. And the denominators in the fraction are the factors in x times x squared plus 4. The first fraction has an x in the denominator. The second fraction has an x squared plus 4 in the denominator. But what I do is I have to put numerators in. Well, x is what's called a linear factor. It's of degree 1. It's what's called a linear factor. And so in the fraction, I have a over x because a is going to be some constant. And a is 1 degree less than x in terms of like degrees of polynomials. X has degree 1, a constant has degree 0. And then the x squared plus 4 here, the x squared plus 4 in the second fraction in the denominator, above it, I'm going to put a linear factor, b times x plus c. And I have to figure out what b and c are, but bx plus c is a linear is linear. So because it's 1 degree, the degree of b times x plus c is, that polynomial is of degree 1, and that's 1 degree less than x squared plus 4. So always in the numerators you put expressions that are 1 degree less than what you have in the denominator. And it turns out that we can figure out what a, b, and c are. Now what we're going to do, and you know, so I'm just showing you how this process works. What we're going to do is we're going to multiply both sides of this equation by the least common denominator. The least common denominator is x times x squared plus 4. Okay, I'm going to multiply it by the least common denominator, both sides. X times x squared plus 4. And when I do that, the equation has rational functions in it becomes now an equation without rational functions, because simplification occurs with the denominators. On the left-hand side, the x times x squared plus 4 simplifies with the x times x squared plus 4 in the denominator, leaving you with 2x squared minus x plus 4. And then on the right side, you're going to have a times x squared plus 4 plus bx plus c times x, because in the first a over x fraction, the x's will simplify out, and then the second fraction, the x squared plus 4 simplifies out. So are there any questions up to this step here? Remember, the goal is to solve for A, B, and C. The goal is to solve for A, B, and C. All right. All right, well, what I'm going to do is I'm going to distribute the A multiply it by x squared and multiply it by 4. And then the x on the right side, I'm working on the right side now of this equation. I distribute the a times x squared, and a times 4 gives me ax squared plus 4a. And then on the right side, I have x times bx plus c. I'm going to distribute the x. X times bx gives me bx squared, and x times c gives me cx. And then what I'll do is I'll group together terms. I'll group together my terms. So the like terms, I should say. So ax squared and bx squared makes a plus b times x squared. And then we have a cx here, and we have a 4a here. Are there any questions so far?
Professor.
Yes, not now.
Okay. I still don't understand like the a plus bx plus c. Like I don't understand that part.
So what happens is when you have an x, here, like all right. So now I'm looking here at this part right here.
Okay.
And I know Tina and Felicity have a question also. I'll get to that in a moment. Good, sure. So I have to put something above the x. So since x is of degree 1, as a polynomial, x is of degree 1, I'm going to put a constant above the x in the numerator. What goes in the numerator is always of 1 degree less than the denominator. The second rational function, the x squared plus 4 here in the denominator, what degree is x squared plus 4?
A second.
Second degree. So in the numerator, I put b times x plus c. What's the degree on b times x plus c?
That's 1. Okay.
That's right. The power on x is a 1, so it's a first degree. That's how you determine what goes in the numerators.
Okay. That makes sense. Okay.
All right. Good question. Good question. Tina, are you good? And then I know Felicity has a question, but Tina, you're good? Okay, wonderful. Good, good. And Felicity, how are you doing?
So this might be a dumb question, but does it only work with the x and x squared plus 4?
Oh no, this is a very general procedure, and we're going to learn more about it on Thursday. We'll do certainly at least another example, maybe a couple, but no, it's very general, and we need to do 1 or 2 more for you to get a feel for it.
Okay. So it works like anything multiplying each other?
I'm sorry?
So it works with like if it's like x squared multiplying x plus 9 or something?
Well, no. Well, like, let me ask you: Are you okay down to this step here?
Yeah.
Okay. Hold that thought, because what of course we need to do is figure out what A, B, and C are, right?
Yeah.
Okay. Now I'm going to go to the next page. And how do we figure out what A, B, and C are? Well, remember what we had was 2x squared minus x plus 4 equals a plus b times x squared plus c times x plus 4 times a. So I have a polynomial on the left side equaling a polynomial on the right side. That means the coefficients have to be the same. If the polynomial on the left equals the polynomial on the right, the coefficients have to be the same. So therefore, we get some equations. A plus b is in front of x squared. So what does a plus b have to equal? Well, the x squared term on the right has to equal the x squared term on the left. So a plus b has to equal 2. Similarly, the c times x on the right has to be equal to negative x on the left side of the equation. So c is negative 1. And then 4 times a on the right side has to equal 4 on the left side. So a is 1. And so therefore, let's just make sure you're okay with A, B, and C here. Let's see if there are any questions on that. Okay, so Sir Fiel, so in this equation here, the so here's the equation. And I want to determine A, B, and C, right? I want to determine A, B, and C. So do you agree? Do you agree that for the equation to be true, the 2x squared term on the left here would have to be equal to a plus b times x squared? Do you agree that they'd have to match? Okay, therefore a plus b equals 2. So I have 3 variables. I need 3 equations, right? With two unknowns, you need 2 equations to solve for the unknowns. I have 3 unknowns, so I need 3 equations. The second equation is going to come from negative x. Negative x has to equal that cx, right? So what's c have to equal? That's right, c would equal negative 1. And then finally, for, hold on here, the plus 4 on the left side would have to equal the plus 4a on the right side, because the constant term for, the second degree terms had to match, the first degree terms had to match, and now the constants have to match. 4a has to equal 1, or 4a has to equal 4, hence a has to equal 1. And so b equals 1. And, all right, good. Good. And what we'll do, I'll just make a few more quick comments. We'll have to finish this up on Thursday, but at least we're, halfway through the problem. So now what we're at is, the integral we can write as the integral can be written as the integral of 1 over x plus 1x minus 1 over x squared plus 4. So the a here, the a was equal to 1. That was a, remember? And then above x squared plus 4, we had bx plus c. So the b was equal to 1. And the c was equal to negative 1. And that's what we have up here. And so what we can do is we can rewrite the integral of that rational function as the integral of 1x dx plus the integral of x minus 1 over x squared plus 4 dx. Okay, and is everybody at least Is everybody comfortable up to that step? We're basically over halfway there. Are there any questions on that? All right, excellent, excellent. So what we'll do is, since officially our class time's over, and thank you for staying the extra couple minutes, we'll finish this up on our next class, So what we did was for this example, let me just go back to here. For this example here, we did the first half of it where we expanded the rational function using a partial fraction expansion. And we ended up at this step here. Okay, and what I'll do then is on Thursday's class, I will continue from this step and we'll finish this problem. Does that sound good? Okay, excellent. Thank you, Snega. Thank you, Tina, Rodrigo, everybody. Very good class by Esther, Tobias, Adriana. Thank you, Eric. Very good class today. Let me stop the recording. Okay, so of course I'm going to finish this problem up in the next recording. So.